Okay, welcome back. This is your professor, Mr. Boone, back here with 11.6, rounding out chapter 11. Going to be two things that we do here. We're going to be talking a little bit about binomial distributions. Remember this when we talked about before, binomial expansion theorem, when we had Pascal's triangle, this and that. We can do the same thing. Kind of weird how this ties in with combinations. And this is going to be a little intimidating when you first look at it, is that the way to expand it is if you have a binomial, two terms, raised to a certain power. What you're going to do is you're going to take the combination of whatever that power is, choose 0, and then look at the pattern. The next term is going to be n choose 1, n choose 2, until you get to whatever that power is. All right? Now look what's going to happen now. The x term is going to be, we're going to start it to that highest power, and it's going to decrease by 1. So if that's a 4, we'll go 4, 3, 2, 1, 0. And then y starts at 0 and goes 1, 2, 3 until it gets to that term. I think if we look at an example here, it might make a little more sense, but this is the general theorem of what we do. All right, so let's see what happens here. All right, let's just look at an example that's already done for us, is that if we have a plus b to the 5th, notice what's going to happen here. We're going to do a combination of 5 choose 0, 5 choose 1, 2, 3, 4, 5. Look at the a term. It's going to start with that power 5 and go 4, 3, 2, 1, 0. B is going to start at 0 and go 1, 2, 3, 4, 5. So these two exponents are always going to add up to whatever that is. Now, after you get kind of set up here, you're going to have to clean that up. You're going to have to figure out, remember how to use your calculator, hit the stack over to probability, and you can get your combinations there, and you'll end up getting something like this. All right, so let's try one. An example here. Here it is. Let's do 2x plus y to the 3rd power. Now, this is what we should get. Let's see if we can do it. All right, so what we're going to do is we're going to start off with the combination of 3 choose 0, 3 because that's the exponent there. All right, we're going to take the first term, 2x, so we're going to raise that to the 3rd. Now notice I did put that in parentheses because we're going to have to raise the 2 and the x to the 3rd power. Y is going to be to the 0 power. That's the first term. Second term is going to be the combination of 3 choose 1. We're going to have 2x to the 2nd power, and then we're going to have y to the 1st. All right, and then we're going to go combination of 3 choose 2, 2x to the 1st this time, and then y to the 2nd. And then we're going to do the combination of 3 choose 3, 2x to the 0 power, y to the 3rd. There it is. Okay, so that's the expansion part. We want to simplify. We should end up with what we see right up there. All right. So what we're going to do, how many 3 choose 0? If you put that in there, that's going to be a 1. Now 2x to the 3rd power, 2 to the 3rd power, this would be 8, and x to the 3rd. And then y to the 0 power, of course, is 1. All right, that's that first term. Now 3 choose 1, if you put that in the calculator, you should get that that is 3. And then if I square 2x, that's going to be 4x squared. And then y to the 1st power, of course, is y. All right, 3 choose 2, that should also be 3. And then we have a 2x, and now we have a y squared. All right, 3 choose 3, that's one way. Anything to the 0 power is 1, and then we have y to the 3rd. Now, is that what we get? Let's see what happens here. Now, if I simplify this term, well, yeah, that is 8x to the 3rd. If I multiply the 3 and the 4, we get a 12x squared y. And then here, 3 times 2, that's going to be a 6, and then we have an xy squared. And then, of course, the last term is y to the 3rd. That does match up. So again, the simplifying process, yeah, it can be a little tricky at times, but that's what we want to see done on that. So that's the binomial expansion, the binomial theorem to expand a binomial. You can use that, and you get a little bit of practice on that on this assignment. So that's one of the two things that we're going to talk about today. All right, so let's go on to the next thing. The next thing is computing a probability when there are basically two things that can happen. All right, we call that a binomial experiment, like when you flip a coin. You're either going to get heads or you're not going to get heads, okay? So success is heads, failures is tails. Let's say that you're rolling a die. You can say, hey, rolling a 3 is a success. All right, rolling another number is not success. So think of it as success and failure. Two outcomes that can happen there. So again, you have to think about what those probabilities are on those cases. So two outcomes, success and failure is what we're going to talk about here. Now, this is the formula that we're going to use to find that probability. What we're going to do is we're going to take the combination. N is the number of trials that we have. All right, R is going to be, well, how many successes are we looking for? All right, and then what you do is you multiply that by the probability of that success. That's what P is. That's going to happen R times. And then you're going to multiply that by Q. Q is the probability of failure. Now, the P and the Q should always add to 1. All right, and then, of course, whatever we have for successes, it's whatever's left over for failures. So it's the number of N minus R is what we have there. So let's kind of look at an example here. I think this will make a little more sense here if we look at a specific example. All right, so G usually makes half of her free throws. So she's a 50% free throw shooter. All right, in practice. Today she's going to try 3 free throws. What's the probability that she's going to get exactly 1 of her free throws? All right, so what we would do there is we'd set up, this is our binomial theorem that we have for probability. It's going to be the combination. Now she's going to shoot 3. All right, and we're saying, well, it's probably of her making exactly 1. Well, remember, the probability of her making that is 0.5. She's a 50% free throw shooter, so she makes half her free throws. That's going to happen 1 time. Now, the probability that she misses is 0.5. Again, I have to add to 1. And that's going to happen 2 times. All right, so if you type that in the calculator, remember, hit 3, hit math, go to the probability, get your combination, choose 1. Then multiply that by 0.5 to the first, multiply that times 0.5 to the second. You should see 0.375. It's a 37.5% chance that she's going to make exactly 1. Okay. Now, as we look at some other things here, you might some other types of questions might be, well, what if she makes at least 1? Well, then you'd have to figure out the probability of 1. You'd have to figure out the probability of making 2. So again, that's that setup there. And then the probability of getting 3. You'd have to add those up, is what you could do there, and figure out that percentage. So that's another way of doing that as well. All right, so this is kind of an interesting problem. I like this one because it kind of relates, because you're going to be doing a lot of multiple choice testing with this online learning and distance learning. Ellen takes a multiple choice quiz that has 5 questions, 4 answer choices for each. What's the probability that she's going to get at least 2 answers correct? By guessing, okay? By guessing. She has no clue, she's going to guess. Well, what she's got to do is figure out, well, what's the probability of getting, if it says at least 2, that's probably getting 2, probably getting 3, 4, and 5, and adding those all together. Now, let's just kind of do some of the setups on some of these. If we did the probability of 2, all right, that's the combination. We have 5 questions. All right, she's going to get 2 right. Now, the probability of guessing correctly, since there's 4 choices, there's 1 right answer, so 1 out of 4. So really, she has a 0.25, a 25% chance of getting it correct. That's going to happen twice, and 0.75 is going to happen 3 times. So that's going to be this number here. All right, now the probability of getting 3, you'd have to go combination of 5, choose 3. 0.25 is going to happen 3 times, and 0.75 is going to happen twice. Now, if you do that, you should get that number right there, 0.0879. All right, now the probability of getting 4, we'd have to go combination of 5, choose 4. 0.25 to the 4th, 0.75 to the 1st. That's going to be that number. And the probability of getting all 5 correct, let's put a plus there. Combination of 5, choose 5. 0.25 to the 5th, 0.75 happens 0 times. That's going to be your number right there. And then you can subtract that. Now, someone might be thinking, hey, I got a better way of doing this. Why don't I figure out the probability of getting 0 and 1, and then just subtract that from 1? Remember that complement idea we talked about the other day? Yeah, you could do that too. That's certainly one way to do that. All right? So again, that's that probability distribution using that formula on that. That can be a little tricky. Once you get the hang of it, though, it's pretty nice. All right, well, that takes care of 11.6. So practice the worksheet, check it with the key, like we always do. And then again, if you have questions, email me, let me know. And then once you're done with that, hey, you're ready to go for the Chapter 11 test. Again, that will be posted and ready for you to go in a Google form. I believe it's 10 questions, multiple choice. We do want to see you get a passing score on that. If not, we'll give you a retry, but I think most of you will do just fine. I hope you do anyway. All right, hopefully you're having a great week. Hang in there, guys. Great to see you. Again, email me whenever you have questions or concerns. All right, for now, we'll see you next time.